Hello, how to solve n to the power of 3 over 2 equals 3 to the power of 3 over 2, solving for all values of n that satisfy this equation. Now, this exponent, I can have it as n power 3 times 1 over 2, and this equals 3 power 3 times 1 over 2. Now, if you have a power x times y, this equals a power x to the power of y, and also equals a power y to the power of x. So applying this property here, that means this is our x, this is our y, x and y as well. So you have n power y, that is 1 over 2, raised to the power of 3 equals 3 power y, that is 1 over 2, raised to the power of 3. Now, if you have a power 1 over 2, this equals square root of a. So let's convert this and this to this form. And square root of n raised to the power of 3 equals square root of 3 raised to the power of 3. So from here, I move this over here. I have square root of n raised to the power of 3 minus square root of 3 raised to the power of 3, and this equals 0. Now, if you have a power 3 minus b power 3, this equals a minus b times a squared plus ab plus b power 2. And my a is square root of n, and my b is square root of 3. So applying these properties or these values for a and b here, I will simply have for a minus b, I have square root of n minus square root of 3 times a squared square root of n to the power of 2 plus square root of n times square root of 3 plus b squared of square root of 3 to the power of 2, and this equals 0. So from here, I have square root of n minus square root of 3. This cancel this, I have n plus square root of n times square root of 3, that is square root of 3n, plus this cancel this, I have 3, and this equals 0. I can equate this and this to 0. I have square root of n minus square root of 3 equals 0. I also have n plus square root of 3n plus 3 equals 0. Let's solve these individual equations. We start with the first one. For this one, I move this over here. I have square root of n equals square root of 3. Square root cancels square root. I have n equals 3. That is my n1. For this, I can decide to move n over here and also move the 3 over here. So we have square root of 3n equals, this is negative 3 minus n. So from here, I take the squares or put part of this equation. This cancels this, have 3n equals negative 3 minus n times negative 3 minus n. So from here, I have 3n equals negative 3 times negative 3. This is 9. Negative 3 times negative n plus 3n. Negative n times negative 3 plus 3n. Negative n times negative n plus n squared. And from here, I have 3n equals 9 plus 6n plus n squared. So from here, move 3n over here. I have 0 equals 9 plus 6m minus 3n plus n squared. So I rearrange this equation. We still have 0 equals 9 plus this is 3n plus n squared. So let's solve this and let's rearrange it well, starting with n squared of n squared plus 3n plus 9 equals 0. To solve this quadratic equation, we make use of the formula method. We write the formula in respect to n. So we'll simply have n equals negative b plus or minus square root of b squared minus 4 times ac divided by 2a. And from here, I have a equals 1, which is the equation of n squared. B equals 3, which is the equation of n here. And c equals 9, which is the constant here. So from here, I have n equals negative b. That's negative 3 plus or minus square root of b squared of 3 power 2 minus 4 times 1 times c, that is 9. This is divided by 2 times a, that is 2 times 1. From here, I have n equals negative 3 plus or minus square root of 3 squared, that is 9, minus 4 times 1, 4 times 9, 36, divided by 2. So from here, I have n equals negative 3 plus or minus square root of, this is negative 27, that is 39 minus 36, divided by 2. From here, n equals negative 3 plus or minus this minus here, square root of negative 1 times square root of 27 divided by 2. So from here, I have n equals negative 3 plus or minus the square root of negative 1 here is I times square root of 27, that's 9 times 3 divided by 2. And from here, I will simply have n equals negative 3 plus or minus I times, this is square root of 9 times square root of 3 divided by 2. So from here, I have n equals negative 3 plus or minus I times square root of 9. We have 3 times, this is still square root of 3 divided by 2. So from here, I can factor out 3 over 2 of n equals 3 over 2 of this is negative 1 plus or minus I times root 3. So we have two complex values for n. We have our n2 because we have gotten our n1 already. This is 3 over 2 of -1 plus I times root 3. And we have our n3 equals 3 over 2 of -1 minus I root 3. These are the two complex values for n. And we also have one real value for n, which is this particular value here, which is n equals 3. So you can as well check by making use of the real value for n. So it's very simple. What you need to do is to have our n equals 3. Insert it here. This is n power 3 over 2 equals 3 power 3 over 2. And n is 3, so we have 3 power 3 over 2 equals 3 power 3 over 2. Now, you can leave it here because this side and this side are the same, or you can simplify it for that. You have a power n over m. This equals the m root of a to the power of n. So applying that here and here, you have the square root, because the square root represents the 2 here, of 3 power 3 equals the square root again of 3 power 3. And 3 power 3 is 27, so this simply means we have square root of 27. And this equals square root of 27. So the both sides of this equation are now the same. So ladies and gentlemen, this is it, and this is how you solve this exponential problem step by step. And don't forget to subscribe and share this video to your friends. Drop a comment on the comment box. I will really appreciate it. Thank you and goodbye.